Ah.
If you mow your yard, can I get extra credit?
If you mow my yard, that would be impressive. As there's no yard to mow. Anyway, let's pray. So I'll begin. Heavenly Father, we thank you for this day. I thank you for these students. Just ask that you to guide our steps today. Help us to understand what went wrong on the quiz and to adjust so we can all do better on the test next class, Lord. In your name I pray, Lord Jesus. Amen. So yes, the reason. Did I ever hit record?
I like dust. I think you did.
Yeah, I wouldn't really recommend coming to my house at the moment. One child just recovered from the flu, and another one that's working on recovering from the flu. But I guess I could be optimistic. Maybe it's just COVID. I don't know. But okay. So anyway, everybody top-hatted? If you have it, write the number down because I want to put this away. All right? 4511. There we go. Now, where did I put Yowzers? Just a second here, guys. No, that wasn't it. Where'd it go? I just opened the quiz like right before I put this thing up. I don't know where it went to. Oh, here it is. I don't want to look at. So this is posted in Canvas, right? You guys see that? Let me download it so I can look at it properly. So the proper way to do anything is outside of Canvas, right? Generally speaking. Okay, so yeah, here we go. Let's talk about these. So number one. My approach to number one would be to look at these and go, circle, right? That's a circle, so that's A, right? Because this is the only equation of a circle here. Then, let's see, up next. Well, this one is like a natural log, but it's been shifted over 4. So this is like natural log of x plus 4. Oh, natural log of x plus 4. So that's C. E to the x plus 2 has a horizontal asymptote of 2. And if you look at that graph, it's got a horizontal asymptote of 2, so that must be that one. So these are the quirks and features of the graph that you can kind of latch onto and use to guide your choices, right? So this one must be that one, which is D, and then minus 4 plus 3 to the, so this one gets really large when x is really negative. So it's got to be that one. All right. So anyway, a lot of you need to think more about which graph looks like which, right? And some simple things you could put on your formula sheet would just be like, how about this? I don't know, something like this is y equals a to the x, right, for a greater than 1. This is y equals a to the minus x for a greater than 1, right? Right? Which is also equal to 1 over a to the x, So if you know about these, then you have a better shot at recognizing those graphs when you see it, right? And then like the natural log graph, what's that look like? Well, generically speaking, that's y equals log base a of x, yeah? And so, a couple features, it's got a x-intercept of 1, right? And it's got this here vertical asymptote at the y-axis, right? So if your graph has a vertical asymptote somewhere, and it looks like a log, well, if it has a vertical asymptote somewhere, it's probably a log, right? If it's got a horizontal asymptote somewhere, in this context, it's probably an exponential, right? So, and those are inverse functions, right? So we kind of expect that interplay. Okay, anyway, that's just some, there was a bunch of homework that was on matching shapes to formulas, and that's what this problem was supposed to echo. And a lot of you got it right, and a lot of you didn't. understandably, we covered the circle material like right before break, and some of you, just haven't studied it yet, so you couldn't do this problem. I get it. Hopefully you'll get it Friday, right? Something like this. Any questions about problem number 2? So the approach is complete the square twice, so you can rewrite it in the format which is recognizable as this, circle equation. So what did we say about circles? What was the key idea altogether? How do we recognize a circle? Remember, if you've got something like x minus, let's say x naught squared plus y minus y naught squared equals to r squared. This is a circle centered where? Centered at x naught, y naught, with radius what? Radius r, right? So your goal with one of these equations that involve circles is to take the given formula and manipulate it until it fits that pattern. And then once it fits that pattern, you can, you're fine. You can just pattern match, right? So, most everybody's here, but let me zoom in a bit actually. So, okay, so any questions there? Yep.
So you said you can recognize a circle by doing the formula that you did down there?
Right. So what I did up here was I took the given formula, right, and I completed the square. So I took half of that, which was 5 minus 5, right? I square that. Then completing the square demands me to subtract the square of minus 5, which is 25. And over here I took half of 4, which was 2. I do y plus 2 squared, but when I do that I've added 4, so I have to subtract 4 to be fair. The 20 over there is still 20, and then I just add 25 and 4 to the other side to get 49. And then you just look at it and go, okay, well that's x minus 5, and that's y minus a minus 2. So the center is at 5 minus 2. A quick way to check your center point, if your center point is right, when you plug it into the formula, you should get 0. A lot of you have sign errors, like plus or minus wrong on the 5 or the 2. For those of you who are like close to the answer but not quite right. The common error is you guys will put like, I have a lot of people putting like minus 5, 2 as the center. Well, that's not right. It's 5 minus 2. That's what makes these terms go to 0, which means that you're at the center of the circle. That formula is the distance squared from the center of the circle. So you should be distance 0 from the center of the circle when you're at the center of the circle. I'm going to stop saying center of circle because it's really tiring. Okay, so next problem. I recognized 16 is 2 to the 4th, and because I could do that, that told me that by the one-to-one property of the exponential base 2, we have 2x minus 3 equals to 4, which gives you 7/2. A lot of people got this right. Yeah. Now you can solve that other ways, but that's one way. What would be another way you could solve this? If you didn't see that, how else could you solve this? Yep. Turn it into a log or something. Yes, here we have 2 to the 2x minus 3 equal to, what was it, 16? So turn it into a log or something. How about we take the natural log of that equation, right? Or you could take log base 2. Thanks. You could take log base 2. I'm going to take the natural log just for the sake of doing it. So I've got natural log of 2 to the 2x minus 3 equals natural log of 16. So that would give me 2x minus 3 times the natural log of 2 equals to the natural log of 16. By the power property of log, we pull the 2x minus 3 out like that. And then this gives me 2x times log 2 is equal to log of 16 plus 3 times the log of 2, which then I can solve for x, right? X is equal to log of 16 plus 3 log of 2 divided by 2 log 2. Which looks really different, doesn't it? But if you want to see why this is the same answer, check this out. Log of 16 is what? 2 to the 4th, right? So this is 4 times the natural log of 2 plus 3 times the natural log of 2 divided by 2 times the natural log of 2. Guess what happens with natural log of 2? It's everywhere. So it's nowhere. And that gives you 7 over 2, which is of course what we found through a much better argument over here, right? But you can fall back on natural log if you're solid on your arithmetic and your properties are logs, right? It is a method. Let's go on. I think the way I've solved in the solution is better than over here, right? Number 4. So let's look at this here. So I wasn't too fussy. Like a lot of you guys said no, and you gave me nonsensical reasons for no. I wasn't generally taking points off for that, but you really should say no because it fails the horizontal line test, or no because the function's not one-to-one. Those are like legitimate answers. Other things, yeah. Some people, I had one person tell me it failed the vertical line test. I'm like, no, no, but I mean, yeah, they're right. If I just take my, if I just take my head and like do this to their test, then I'm okay, I guess, or something like that. I don't know. Yeah. So the other one, on the other hand, does pass the, the horizontal line test. So we can find the inverse. And the way to find the graph of the inverse, and this is not complicated, guys, but you need to learn it. Like a lot of you you're just like guessing. You're just making a guess. Like a lot of you reflected it over the x-axis or something like that, which is, pretty, but wrong. So you just have to take the points on the graph that's given and flip the x and the y. That gives you corresponding points on the inverse functions graph. So 4, 6 flips to 6, 4, 6, 4 flips to 4, 6. Minus 6, 8 flips to 8 minus 6. All right, that's the key idea when you're making the graph of an inverse function. The x and the y coordinates in the points on the graph flip over for the inverse. This is the relation. And another thing, some of you who were close to right, but a little bit wrong, I don't think I took points off for this, but I would take points on the test. Some of you have continued the lines. Like it didn't stop here, it went on and on, right? But this is not a line, it's a line segment, right? So the domain for this function would be like minus 6 to 6, right? And the domain for the function should be the range for the inverse function. The range for the inverse function is minus 6 to 6. See, some of you have drawn lines that go on. That's wrong for this problem. So you got this problem wrong. Yep. I don't have to qualify that. Like pretty much, well, wait a minute. I'm not sure if this was the section. One of my sections, everybody got it wrong. Pretty much.
So we should get her a point.
So, no, we solved many of these in class. And there was a bunch of homework problems on these. So you should learn them. But I understand that this is something that we're far enough away that you're not used to. Yeah. Let me work a few of these since we had so much trouble on this one. Yeah. Let's just start by talking through the solution of this one. So remember the 4-step process? We start by writing y equals f of x, which I did. And then I solve for x. So solving for x is a few steps. I first by subtracting 2 to the other side. All right. After I'm done with that, I multiply by the denominator to isolate x over here. But you see I've got an x on both sides, which is annoying, but we can deal with it. Next step, multiply it out. Multiplying that out gives me xy plus 3y minus 2x minus 6. I mean, that's how I FOILed it out. However you multiplied it out, it's your business, but we should all agree that we have these 4 terms here, yeah? Equals x. Now I want to put all my x's on one side, right? So So I do xy minus 3x because I collect terms, right? Minus 2x and then minus that x gives me minus 3x. And I put my 6 and my 3y to the other side like that. Factor out my x, and then divide by y minus 3. I have solved for x. Whenever you're done with that, that will be the formula for f inverse of y. Right? So f inverse of y is 6 minus 3y over y minus 3. Again, an important thing to notice is that the domain of the inverse function is the range of the function. Right? So because the domain of the inverse function is clearly everything except for 3, right? 3 makes the denominator have division by 0. So we have to throw out 3. That makes that the range of the original function. So the range is just this. Thank you. You're welcome. But yeah, a lot of people had a lot of problems with this one. Yeah. And a lot of it, unfortunately, has revealed deeper algebra problems with you guys. And so those, in some sense, are really more troublesome to me than not being able to work this problem. Maybe your technique, your idea for solving this problem wasn't wrong, right? Maybe you had this idea, but your algebraic, like how you tried to carry it out algebraically was, very, very flawed. And so let me show you a couple of the mistakes that I saw. And I hope that this won't be one of those times where I show you a mistake that you then, repeat. So I'm trying not to spread the mistake. I'm trying to warn against it, all right? So please pay attention to the fact I'm not telling you to do this. I'm telling you, don't do this. So I saw this, all right? And I basically saw this go to, now people wouldn't write this down usually. What they would write down was just, this is not true, right? What's the deal? You can, if we had x plus 3 upstairs over x, that's true. When we have the addition in the numerator, you can do this, right? This is, in fact, x over x plus 3 over x, which is 1 plus 3 over x. But upstairs, this is not true. This is, you could say it's bad algebra, right? There's a professor here who I like, and whenever he sees something like this on a student's page, he'll just circle it like this, and then over here he writes in bold capital letters, bad algebra. So I haven't done that. But it wouldn't have been wrong if I had, because this is a very serious mistake. Do not do this. All right? So, and if you want me to give you numerical evidence that it doesn't work, like, I don't know, try it out. That's like 5 over 5 plus 3, right? Is this equal to 5 over 5 plus 5 over 3? Well, that's 1 plus 5 thirds, which is what? 8 thirds, right? What's this equal to? 5 over 8, right? Is 5/8 equals to 8 thirds? It's not, right? This is not an identity. You can easily verify that it's not how algebra works by plugging numbers in. If you're in doubt, if you're about to make an algebra step and you feel like, maybe this step is not right, stop yourself for a second, try a number, see if it works. Yeah. Uh-oh. Yeah, sure, there could be. Yeah, so if I put an x instead of y there, all you had to do is just take my answer and change y to x.
Right. Okay.
That's just like the step 4.
So you have it in terms of y equals, or in terms of y because it says f1.
Yeah, I have it in terms of y because that's what the question asked for, but you could put it in terms of x. I wouldn't have taken points off for that. If you had the right formula and I took off points because it was an x, you can tell me about it. I'll give you your point back, yeah? Because I didn't intend to do that if I did. Okay, so let's work another problem here, yeah? Let me just do a couple of these just to try to help you guys. Let's see here. Let's work one that's really different. So suppose you have f of x equals to x plus 3 over, 1 minus x, all right? You want to find the inverse function for that. So what do we do? So find the formula for the inverse. So I write y equals to x plus 3 over 1 minus x.
Yeah.
Now I solve for x. So I've got 1 minus x times y equals x plus 3. Yeah? And then, so that gives me y minus xy equals x plus 3. Put all my x's on one side, so that gives me, minus x minus xy is equal to 3 minus y. I can factor x out. And then I can solve for x, right? So many minuses. Let me absorb them. Let me clean that up a little bit, right? So we can rewrite that as, minus y minus 3 divided by minus 1 plus y, right? So the minuses cancel. We've got y minus 3 over 1 plus y. So for this one, I get that f inverse of y is equal to y minus 3 over 1 plus y. Now, if the question like you asked was about x, what would the formula be for f inverse of x? If I wanted to know what f inverse of x is, I just switch the x to the y to an x at the end. Now, some of you have been taught to switch the y and the x at the start of this whole argument, and that's fine if you did. If you still have that in your mind from your previous algebra class, more power to you. If you can do it right. Yep.
Can you go over that same problem switching the y and the x in the beginning?
Oh, I'd rather not. Yeah. I mean, I can do that after class, but I don't want to, here. I better not. Okay, so my question for you for this one is, what's the domain and range of the function? Let's, that's not so much on this test that much, right? I just asked about the range on test 3, right? Mm-hmm. But test 2 asked about domain. Test 1 asked about domain, didn't it? Mm-hmm. A little bit, I think. So that's an important question, generally speaking, for this class. How do you figure out the domain of a rational function? What's the domain of f? And what's the domain of f inverse? What's the one thing we can't put into the formula, right, for f? 1, right? We have to avoid 1. So we do minus infinity to 1, 1 to infinity. So we're taking 1 out for the domain. What's missing from the domain of the inverse function? Not 1. This one minus 1 is the troublemaker. So we do minus infinity to minus 1. Right. What's the graph of this function look like anyway? Well, anyway, we'll talk about that later. We don't need to talk about that right now. My question then is, what's the range of the function? Well, the range of the function is this, right? So the range of this function is the domain of the inverse function. And by the way, if you wanted to know what the range of the inverse function is, it's the domain of the function. So there's this duality between domain and range for function and inverse function like this, yeah? Let me work one more of these, and then we'll go on, okay? So I guess this was example 1. So my example 2 is going to be really different, yeah? Example 2, f of x equals to 4 plus the log base 3 of, 3x minus 2. Find the inverse function formula for this one. Let's find f inverse of y. How would you do it? How do we find f inverse of y here? If you don't mind, I'm going to erase my algebra from the previous example here so I can work up there. Can I erase that? Okay. So what's my starting point? My starting move, I write y equals the formula, right? Y equals to 4 plus the log of base 3 of 3x minus 2. So when I'm faced with something like this, I'm trying to solve for x, right? But the first thing I need to do is to isolate the log, right? So isolating the log, I get y minus 4 is log base 3 of 3x minus 2. And then how do I get rid of the log to get x on its lonesome? What do I do? The natural enemy of log base 3 is the exponential base 3, right? So we do 3 to all of this and 3 to all of that. Now 3 to all of this is just 3 to the y minus 4. That is what it is. But 3 to the log base 3 is whatever's inside. So that's just 3x minus 2 because 3 and log base 3 these are inverse functions in this sense, right? They cancel out by definition of the logarithm. And now I can solve for x. One more step. 3x is equal to 3 to the y minus 4 plus 2. And so x is equal to 1/3 of 3 to the y minus 4 plus 2. So f inverse of y is literally, and I mean, I guess we could clean this up. What's 1/3 times 3 to the y minus 4? Can you guys simplify that? Y to the what? It's going to be 3 to the what? If I multiply this times this, what do I get? I get 3 to the minus 1, right? Right? Which then gives me 3 to the y minus 5. And then 1/3 times 2 gives me plus 2/3. There you go. So there was nothing like this in your homework, was there? But this is a logical question that you could be asked because this is using the concepts that were covered in the homework, right? The homework started by finding formulas for inverse functions, right? But at that time, we didn't know exponentials and logs, but now we do. So this becomes a reasonable question because we know exponentials and logs. Although admittedly, it's a challenging question because I'm combining the two things that we've learned, namely how to find formulas for inverses and also algebra of exponentials and logs. Any questions? Okay? Thank you. Yeah, cool. So let's go on here before I run out of time. There are other things to talk about here. The next problem is, shouldn't have been trouble for a lot of people, but it was. And I think so. If you want to get this kind of problem right, you need to have, clear in your mind what are the properties for the logarithm, right? So one of the basic properties for the log is that the natural log of e to the x is just x again, right? And the natural log of e to any power is just that, whatever that power is again. So like natural log of e to the 8 is 8. Natural log of e is 1. And so, yeah, that's just x minus 6 equals to 8, which gives you 14 for x. Yep. The next one, so by the one-to-one property, if we have log base 3 of something equals log base 3 of something, we get the arguments 3x minus 1 equals to x plus 5, which then I subtract x to the other side, add 1 to the other side, and I get 2x equals to 6, which gives me x equals to 3. So a lot of people got these problems right, and that was good, but not everybody. So problem 8. There was a lot of partial progress on problem 8. I caught a lot of you guys off guard by putting this plus 2 here, which was kind of mean, but I only took off a half a point if that was your only transgression, like not switching the 2 to a log of 100. Do you see why that's true? What's 100? 100 is what? It's 10 to the 2, right? So if you've got a naked number, you have to convert it to like, log of 10, log of the base to that number, basically is how it goes. If I had a 3 there, I would have put log of 1,000, right? If I had a third there, I would have had minus log of 1,000, so forth. Yeah. Hey, but now you've seen the trick, so you know how to do this problem, right? Yep.
So you changed the 2 to the...
2 is equal to log of 100 because, I mean, to show you the steps, so 2 is equal to log of 10 to the 2. Yeah, which is log of 100, right? If this was a natural log problem, right, you would have done this. 2 is natural log of e squared. 2 is also log base 3 of 3 squared. You know, we could do this all day, right? But I did 10 because we're working with the common log in that example. Yeah. But, and then, so a lot of people had something right about this problem. So, like I said, there's a lot of partial progress here, but a lot of you were missing the 3 down here. That 3 matters. That 3 has to be accounted for, and it's accounted for by y plus 1 to the 3rd power, yeah? Now, problem 9, a lot of you just kind of ignored the square root because you didn't know what to do with it, but that gives you the half power out front, and then you can go from there and pull the powers down, right? So, again, there was a lot of like half correct answers there. I'm kind of thinking about switching this to a multiple choice format for the test, to be honest with you guys. I think it might be easier for me to grade. and also would probably show me about the same understanding or lack thereof for you guys, yeah? But, what's that?
I'm just talking. I'm just looking at...
Talking's fine? Problem 10? I don't know, there's a smattering of you who did not have a calculator, and I'm sorry about that, but do try to have a calculator for the test. It might be more of an issue for the test than for this quiz. And so there are various ways to do this. Some of you did this by just number crunching, which was kind of funny. You're just like, I just put 2 to a power and messed with it until I got close to 5, and I got 2.32. I'm like, huh, I guess that's a method. It's a horribly inefficient time-wasting method, but it is a method. However, that's only a method if you tell me that's what you did. See, if you just write down 2.32 without any work, then I'm going to take off points. You have to show your work, all right? Otherwise, I would just have multiple choice and free myself of the trouble of giving partial credit. But because I give partial credit, I expect full work to be shown. But sometimes I'm more severe on the test in terms of taking points off for lack of showing work than I am on the quiz, yeah, generically speaking. Okay, next one. But that one, so I took the natural log of both sides, and that gave me log 5 over log 2. Now, some of you took log base 2 of both sides and got x is equal to log base 2 of 5. Well, log base 2 of 5 is equal to natural log of 5 over natural log of 2 by the what? The change of base formula, right? So log base 2 of 5 by change of base formula is natural log of 5 over the natural log of 2. So if you've got everybody has a calculator, right? That has natural log. Let me rephrase that. Everyone is expected to have a calculator that will do natural log for the test Friday. I'm not saying that you actually do, but it would be good if you did. Yeah. And so in terms of a problem with a calculator, right? Since your calculator does not have log base 2 on it, maybe that's not true either. Maybe you don't know how to use the log base 2 function on your calculator. Like my calculator, I didn't know how to do log base 2 on this calculator, right? When I started teaching this material, like right after test 2. But at some point, about 2 or 3 lectures in, I found out, oh, there's a log sub box button on this. And that's the log base, I've got a log base 2 button here on the, it's like my upper, it's the most, anyway, it's here. Maybe your calculator has log base 2, you just haven't discovered it yet. Anyway, what I was trying to get at was if you're unsure about how to use log base 2 on your calculator, using natural log to solve the problem will bring you to formulas in terms of natural log. Any calculator that's a scientific calculator will have a natural log on it. Or you should ask for a refund, like for sure. This one, we combine x and x minus 6 by properties of logs, like so. Some of you just dropped the logs and made this x, like you went from this to x plus x minus 6 equals to 2. This is not correct. So if you got the answer of 4, you probably did that. Like, do you know what I'm talking about? So you guys, instead of, you just like basically ignored the log 4 and just traded this for x plus x minus 6 equals to 2. This is just nonsense, right? Whoa, but it's standard nonsense, like, because I had probably 25% of the class do that. So it's popularly agreed upon nonsense, but nonsense nonetheless. And yeah, that's what's wrong. So we have to use property of logs. It gets to here, and then we exponentiate both sides. I get 4 squared, which is 16. So I have x times x minus 6. I put everything on one side. I factor. We get 8 and minus 2 as potential solutions, but minus 2 is extraneous because when you plug it back in, it doesn't work, right? So that's how that goes. Problem 12 was probably the hardest problem on the quiz. This is a quadratic substitution problem. So you have to recognize that as e to the x squared, make a y equals e to the x substitution, which gets you to y squared minus 3y minus 4, which factors y minus 4 times y plus 1. And then either y equals to 4, y equals to 1, which translates into e to the x is 4 or e to the x is minus 1. But e to the x minus 1 has no solution because e to the x is positive, right? So we get natural log of 4 as our only solution here. And there, I think, are a small minority of you who have managed to get natural log of 4 for the wrong reasons. And I'm not sure how that happened, but that's every so often there's like a series of wrong reasons that get you to the right answer. Watch out for that. If I didn't take points off, don't bring it to me and say take points off, but find out for yourself the right way to do it, right? I mean, so you'll, anyway, do think about whether or not, if you have a different way of doing it than I did it, you should think about it and ask me about it probably, if you're unsure. Any questions about this? This we did not know. So I have much more sympathy for you if you missed this problem than, say, the inverse function problem. The inverse function problem, I'm pretty sure we did at least 3 examples for in class, and they tend to take a while, so you should have noticed it, you know. This one, we did it, and we went on. There was like maybe 2 examples on this, and there's maybe 2 homework problems on this. So it would be understandable if you missed this one. It's kind of a sneaky thing, but now I put it on the quiz. You know, I think it's important, so I hope you, you know, learn how to do it if you haven't already. Now, problem 13. A lot of you got problem 13 right. Yay! So we can solve 2 equations and 2 unknowns. This is wonderful. That's actually really important. In terms of applications, this thing comes up so much more than many of the other things I've shown you here. So if you got 13 right, wonderful. If you didn't get 13 right, the way to solve it is to solve one of the equations for y, right? And plug it into the other one. That gives you just 1 equation and 1 unknown that you can solve, right? Or, well, I think problem 13 does not yield itself to adding equations, right? The problem 13 to me is a quote-unquote substitution problem. Problem 15, on the other hand, we'll see is different. Problem 14, I asked you to solve for a, I think. Some people did this. Some people even got this answer. So there are a few. I'm not sure if anybody in this section did, but you know, I can't remember. I grade all 4 sections at once, guys, so like I forget, you know, who did what where. But anyway, so to get rid of the exponential, we take the log of both sides, and then that gives me log of AB, but that by properties of logs, log A plus log B. And then I isolate the A, log A, like that. I raise both sides to the 10 power. That gives me this. But then that's by properties of exponentials, 10 to the log C, 10 to the log, natural log C, 10 to the log base 10, B inverse These are inverse functions, so that gives you b to the minus 1, which is division by b. So this is like the problems at the tail end of homework 12, right? And then finally, problem 15. So some of you had kind of sort of the right setup here. A smattering of people got c equals to 3. We should have all had c equals to 3. Like that's easy pickings, right? Because f of 0 is what? The y-intercept, right? Which is the constant number that appears in the polynomial formula. This is a general truth, so it's still true here. So c equals 3. But 1, 6 and minus 1, 4 are pretty nice because they give you a plus b plus c is 6 and a minus b plus c is 4. The thing is, we already know c is 3, so we've already got 2 equations and 2 unknowns, which are actually pretty here. This one, I think adding equations is obviously the way to go, right? So add equations, I get 2a equals to 4, gives me a equals to 2, plug it into the other one, I get b equals to 1, put it all together, I get this. I think about 10% of the class got this right. More people got this right than they got the inverse function right, I would say. Anyway, I want you guys to get all of the problems right Friday, so I hope you can figure out what went wrong. Now do remember, the quiz is a pretty good picture of the test 3, but I might test on some of the homework that was covered more recently that I haven't put on the quiz yet. So there might be like the last 5 problems in homework 13, I might test on that. Just a warning.
What would you recommend putting on the formula?
I would put everything on the formula sheet, of course. Things that are true mostly.